In the last lab, we set up routing statically. That means that we had to manually define all the routes in our network. We had to tell our routers where to specifically move everything. Now that worked okay with the small network, but as our networks start to grow, configuring every single router might not be ideal. We might have dozens or hundreds of networks, and we might have several routers, and so if we have, let's say hypothetically, 100 different subnetworks and we had 3 routers, we might have to define 300 static routes on those routers. Not something that you might want to do. So what we can do is use dynamic routing. So we are going to use OSPF. That's an algorithm used to do dynamic routing. It stands for Open Shortest Path First. It's just the version 2. It's a way that we can tell our routers essentially to talk to each other and tell each other about their networks so that we don't have to define so many static routes. Now let's cable up this network. Now for this lab, looking at our diagram, you can see we've got computers plugged in directly to routers. I just wanted to go through this just to demonstrate that it can be done, and also save you a little bit of time setting up the switches so you can spend your time configuring the routers and getting everything working. You can see, remember I said that a router is basically a computer, and we're connecting computers to them because we're connecting 2 of the same class of device. We have to use a crossover cable. So we'll connect the computers to the routers using crossover cables, and we will connect the routers to each other using the serial connections. So let's go ahead, and I'll do this in Packet Tracer. Let's add 3 1941 routers, 1, router 2, router 3. I'll change the labels on those right now just to make sure I'm doing everything in the right spot. Oh my gosh, there we go. Not F2, R2, and R3. That looks good. The only other hardware we need, only other devices are the PCs, so I'll click End Devices, add a generic PC there, another one and another one over here, just trying to match the diagram. I'll call this one Computer A. This one's Computer C. I'm doing this a bit out of order. It doesn't matter which order you do it in. Computer B. Okay. Now we need to connect everything with cables. Not that loopback though, remember that one's special. And I'm not going to do the console cables here. So in this diagram I use a red line to represent a crossover cable. Remember in Packet Tracer it's a dashed line. So I'm going to connect Fast Ethernet 0 to Gigabit Ethernet 0. Then I'm going to connect G00 to my PC. See, I was consistent here. The diagram has me connect all of my PCs to the Gigabit Ethernet 0/0. Now remember, why are these lights red right here? It's because on routers, by default, all the interfaces are administratively down. That's the out-of-the-box factory fresh setting. Now if I try to connect these with the console, or sorry, with the serial cable right now, what's going to happen? I have no place to attach it. There's no serial port yet, right? So what do I need to do? Yep, bring up the physical configuration, power off the device, drag on my serial connection, power back on. Do the same thing for all 3 routers. They'll be rebooting as soon as I click that power button. You can see the boot progress indicated by those pound symbols. Now I should be able to connect these cables. So I'm going to click the serial connection with the clock, that will be the DCE side. So I'll connect that to S000, connect it to S001 over here according to the diagram. And I want my DCE side there, serial 000 to 000. My DCE side is going to be on router 2 for the last connection. Only have one place to put it. Okay, so my cables look good. But again, everything is still administratively down, so we need to fix that, right? So I don't have to delete the configuration because I'm starting with factory fresh hardware inside packet tracer, but you would need to do that using physical equipment if you needed to. So let's go ahead and come to the router interface configuration. Okay, I just made a Ninja edit to add the login command. Let's go ahead and configure our routers. We need to do this on all 3 routers. I'm going to come to the CLI tab, enable, I'm going to configure the terminal, line on 0 for our console connection, logging synchronous, hit the tab to make sure that I spelled that correctly, password class, login, exit, enable secret Cisco, banner MOTD, keep out. There, that message does not require me to spell unauthorized or access. That looks good. Let's come to router 2. I do not want to continue with the initial configuration dialog. I never want to do that. So en config t line, whoops, config t line colon 0, logging tab, sy tab, it'll give me logging synchronous, password class, login, exit, enable secret Cisco, banner MOTD, keep out. So you should know what all those commands do. Hopefully you're able to just whip through them super fast. Oh no. I did the bad kind of typo where it tries to look up EB. I'm going to pause the video. And that command took forever to finish, but let's go here. En, we're going to config T. I'm going to say no IP domain. Look up. Oops. Okay, no IP domain lookup. So I am going to end. I'm going to go back. So what would happen theoretically if I push EB here? Okay, now it doesn't try to look that up. So that no IP domain lookup can be useful. That's just extra. It's not in the instructions, so I'm not going to make you do it right now. So I'm going to go back to en, config t, line con 0, logging synchronous, password class, login, exit, enable secret Cisco, MOTD, keep out. Okay. So that's all the tedious stuff for the routers. Maybe you think it's all tedious, but that's the most tedious stuff, I think. Now we're going to configure the interfaces on router 1 according to our diagram. So if we look at our diagram, what would I need to change here? See if you can do it just by looking at the diagram. We need to change host name to R1, and then interface G00. I have to give this an IP address. So do you remember that command? See if you can remember it. 192.168.1.1. I can't use the slash notation here, so I've got to use 255.255.255. 0. It's the same thing as /24. Then what else do I have to do here? One important command. No shut. So change state to up. So that one's good. We're good to go there. I need to configure S001. So I'll say int S001 IP address 192.168.13.1. Whoops. 255.255.255.252. Need to put that net mask in there. No shut. Because this is the DTE side and not the DCE side, I don't have to set the clock rate. If you look at my diagram, I need to configure the clock rate on S000. So int S000 IP address 192.168.12.1 255.255.252 again, so that's /30. Only 2 computers can be on that network. Hit enter, no shut, clock rate. I've got the clock rate memorized. You can use the lab guide. That's all fine. So my gigabit Ethernet, I got green blinky lights, S000 and S001. They're still red. So think, why are they red? Because the other interfaces on their connecting interface is not turned on the other router that it's connecting to. So let's come down to these instructions. Did I do everything right? Hostname G00, I set the IP address, I said no shut, changed it to up. So on 000, I set the IP address, I set the clock rate and no shut. So all that looks good. Looks like I did it correctly. And I did use the correct subnet masks. So that is good. We did have a loopback. Where was my loopback? So loopback is on router 2. So let's see. I am going to set the IP addresses here on router 2. And see if you can figure out what they are before I do them. Hostname R2. So I'm going to configure G00. Think, how would I do this? G00 IP address 10.0.0.1 255.255.255.0. No shut. And as soon as I hit enter, we should see green blinky lights. And we do, so that's good. S000 int S000 192.168.12.2 255.255.252. What did I do wrong there? Invalid input int S000. What's wrong with this command? Invalid input. Okay, it's still too early in the morning. Haven't had my caffeine yet. So do you see what I did wrong? Why is this invalid? It's invalid because I was mixing 2 commands together. So it happens. I was mixing up the interface configuration with the IP address command. So int S000. So when I do int S000 and hit enter, now I'm configuring that interface. Now I need to say IP address 192.168.12.2 255.255.255.252. No shut. Now we got some more green blinky lights. So everything's good there. That interface is up. Now we need to do S001 int S001. And this is the DCE side, so I have to set the clock rate. IP address 192.168.23.1 255.255.255.252. 252. No shut. Clock rate 128. I also need the loopback. So int LO0 IP address 209.165.200.225 255.255.255.224. Okay, so that router should be good to go. And let's look at router 3 now. If you can configure all these interfaces on your own, if you don't know the commands, great. Let's see if I can do it without messing up a single command. Can it be done? Int G00 IP address 192.168.3.1 255.255.255.0. No shut. We got green lights there, so that's good. I like to see those green lights. Let's do int S001 next. IP address 192.168.23.2 and 255.255.255.252. No shut. This is the DTE side, so I don't need to do any clock rate. We got green lights there. That's good. All right, let's just do int S000 IP address 192.168.13.2 255.255.255.252. No shut. Clock rate 128,000. And we got green lights across the board, so this is good. So, should computer A be able to ping computer B now? There's a question for you. Well, no, right? You know we can't yet, because we haven't even set the IP addresses on those computers. Let's just double check. We finished router 1, we finished router 2. We finished router 3. And just double checking, I think I did everything here that I was supposed to do and got it all working eventually with a few mistyped commands, but you know what? That just happens. So let's configure the client. So computer A, B, and C. So computer A, we'll go to desktop IP configuration. So its IP address should be 192.168.1.3. The net mask it recommends for us is good. 192.168.1.1 for our default gateway. It's good. No need to save, just click the X's to close everything. Computer B. The IP address will be 10.0.0.10. If I hit tab, notice that the subnet mask it recommends is not what I want, so I have to change that. My default gateway will be 10.0.0.1. Computer C, desktop, IP configuration. 192.168.3.3. Subnet mask it recommends is good. 192.168.3.1. That is good. Okay, now let's test connectivity. We're going to test a lot of different connectivity. We're going to ping from PCs and we're going to ping from routers. So I'm just going to come up to my diagram because I didn't put the IP addresses here in Packet Tracer. So it's going to, I have not memorized all, let's see, how many IP addresses do we have here? Like 4 per router. We have about 12 IP addresses. I haven't memorized them. What should computer A be able to ping right now? So think about that for a second. Pause the video if you need to. Let's start testing. So I've got computer A pulled up here. I should be able to ping my default gateway. If I can't do that, I'm not going to get anywhere. 192.168.1.1. Okay, got a reply, so that's good. There should be a reply. They're on the same subnetwork. Now I should also be able to ping these local interfaces on the router. Ping 192.168.13.1. Okay, that's good. Ping 192.168.12.1 should work. But now let's try pinging just the next hop. So if this router needs to send a packet off to a different network, it's got to go to router 2 or router 3. So let's ping those interfaces. I'm going to use the up arrow key and just change that 12.2 to change it to 12.2. Hit enter. It's not working. So think about why that's not working. It's not supposed to work at this point. You can ping 13.2 also will not work. So think about why. Computer A knows about 192.168.12.1 and 13.1 because they're router 1, they're configured on that router, so computer A can get there. Router 2 knows about 192.168.12.1, but router 2 and router 3, they know nothing about this 192.168.1.1 network. It's essentially hidden from them. So the packet is being routed to those routers, but that router has no idea how to send it back. So that's something that we need to fix. So it'll be the same. Router or computer C will be able to ping its default gateway. Ping 192.168.3.1 to get a reply. That's good. We should be able to ping 23.2, and we can. We should be able to ping 13.2, and we can. That should be about it. We can try 13.1. Not going to work. Same thing's happening. So 13.1 is connected to router 1. The packet can get there, but it can't get back. Because router 1 knows nothing about the 192.168.3.3 network. So we're good so far. Now, we've done pings in this class a lot with computers. You can actually ping from the routers to test connectivity. It's a really good idea to ping from the router. So I'm going to bring up router 1 right now. Was it class or Cisco? Enable Cisco. So here I am in privileged exec mode on router 1. So I can actually run ping commands from my router. Ping is probably the most universal utility you'll find out on any operating system that can do any kind of networking. And these routers can do networking. So let's try to ping. What could we ping from router 1 to test connectivity? Let's say the ping from computer A to 192.168.13.2 failed. Well, let's see if my router can ping that. So I'm going to ping 192.168.13.2. And it worked. So Windows tries 4 times, Cisco tries 5 times. So we had 5 out of 5, 100% success. And if you try it, if 1 or 2 fail, but the last 3 work, that means it's working. So that went straight from router 1 to router 3 and back. So these can ping each other successfully. So that's good. I also want to check R1 to R2. Is that connection working? So I'm going to ping 192.168.12.2. Yeah, that's working. So that's good. If these direct connections between routers are not working, nothing's going to work. So I'm going to close router 1. So I've tested the line between R1 and R3. I've tested R1 to R2. I have not tested R2 to R3. So I'm going to bring up R2. So I'm still in config mode. So the ping is just a regular privileged exec mode command. So how would I ping router 3 right now? What command would I use? Think about it. Here I have to run do ping 192.168.23.2. So here I am on router 2. I want to ping this IP address. Works. So here's a question for you. I'm on router 2. Should I be able to ping 13.2? When I hit enter, what's going to happen? Success or failure? Success rate, 0%. Okay, so that ping fails. So let's look at why it fails. So let's look at router 2's routing table. So I'm going to run do show IP route. Now I'm trying to ping 192.168.13.2. I don't have a match for that in my routing table, so my router has no idea where to send that. It shouldn't work at this point. It should work eventually, but not right now. So essentially, when we're just setting up and getting the IP addresses and cables all set up, we should just be able to ping interface to interface. We shouldn't be able to ping much more beyond that quite yet. Okay, so let's keep going down. Don't mean to make you dizzy. We configured the clients, we tested connectivity. Now we're going to configure OSPF. All right, so I'm going to close that router, close that router. So we're going to come to router 1 first. So I'm going to come config D. If you're not already in config mode, I'm going to use the command router OSPF1. Now the 1 is fairly arbitrary. It's just a process identifier. Just always use 1 unless you have a good reason not to. At least in this class, always use 1. Now, maybe the trickiest part about setting up OSPF. We have to tell OSPF what networks to use and what area to assign them to. The area defines who our routers are going to share information with. If you have a very big network, you might not want all your routers sharing information with everybody else, so you might put them in separate areas. In our case, we are going to put all of our routers on the same area. So let's look at these network commands. So I would say network 192.168.1.0. And now I've got a wildcard mask. This is essentially the opposite of a subnet mask. Somebody back in the day thought wildcard masks made sense instead of using subnet masks. It was basically a coin toss. That's the guy who came up with this notation of this protocol. Honestly, he basically flipped a coin and said, should I use subnet masks or these wildcard masks? And he went with wildcard masks. 0.0.0.255 area 0. So look at that network statement. I'm going to scroll up to my diagram. So here we've got router 1. So I'm configuring OSPF on router 1 right now. Now, how many networks are connected to router 1? How many subnetworks do you see? Well, there are 3. I don't give you the network address here, but we can figure it out. 192.168.1.0/24 is the network address for computer A and that G00 interface. So I have to configure OSPF to basically say, we are going to share information, we being router 1. Router 1 is going to share information about the 192.168.1.0 network with that reverse subnet mask with everybody on area 0. Now we need two more network statements because router 1 knows about 3 in total. It also knows about the 192.168.13.0 network. Remember, 13.1 is the first usable IP address. The network is going to be .0, and the wildcard mask is going to be 0.0.0.3. We essentially take 255.255.255.255 and subtract the subnet mask. 0.0.0.3 area 0. And this router knows about one more. 192.168.12.0. 0.0.0.3 area 0. So that is good. We come down, let's see if I got these commands right. 12.0, 3 area 0. That's good. Now I can change my router ID. This is optional. Your router ID should be unique on its network. Cisco will assign one to you automatically, but here we can set this up 1.1.1.1 so that when we show information about OSPF, we can see a friendlier name. So router 1 is going to be 1.1.1.1. That's just going to make sense rather than just some random set of numbers. So you can see there, it gives us a message, reload or use clear IP OSPF process for this to take effect. So we can do that. I'm going to type end here just to jump out. Clear IP OSPF process. Reset all OSPF processes? Yes. Okay, so that's good. So that time we do have to actually type yes when Cisco asks us a question. We can use the command show IP OSPF neighbor. We don't have any neighbors yet. Neighbors are the routers who we're sharing information with. So if you're working as a team configuring routers, you might see something if one of your friends finished. So I'm going to come to router 2. How many networks does router 2 know about? Scroll up. 1, 2, 3, and 4. We're going to hold off on the loop back for just a minute so we can watch how OSPF works. We need to configure these 3 interfaces. So I'm on router 2. I'm going to exit out of config IF and just say router OSPF1 to turn on OSPF. Now we need to do my network statements. Network 10.0.0.0 0.0.0.255 area 0. It also knows about 192.168.12.0 and I'll put that network statement in there. 0.0.0.3 area 0. Now you'll realize that I entered that exact same command on router 1. Well, they both know about this network, so they're both going to define it. Network 192.168.23.0 0.0.0.3 area 0 router ID 2.2.2.2 and clear IP OSPF process. Yes. Show IP scroll down. Let's just double check we've done everything right. OSPF neighbor. Okay, now I've got a neighbor here. So router 2, now it's seeing that we've got a neighbor with ID 1.1.1.1. So that is router 1. So that's good. they're starting to share information now. So that's good. So let's go to router 3. So how many networks does it see? Scroll to my diagram. Router 3 sees 3 networks. Configure terminal, router OSPF 1, network 192.168.3.0, 0.0.0.255. So that's going to teach this router, tell it to share information about this network here. It's going to share it with everybody in area 0. Network 192.168.13.0, 0.0.0.3, area 0. And one more. I'll push up. Here's a shortcut. Okay, so it should be sharing information now. So if router ID, router dash ID 3.3.3.3, and to bring me all the way back to the privileged exec mode, could type exit a bunch of times, but end will take me there quicker. Clear IP OSPF process, yes, show IP OSPF neighbor. So I've got 2 neighbors here. That is good. And you can see some messages popping up. Everything's good. You'll see some status messages. It's just kind of in the background, these routers showing us that they're sharing information. Now let's see. Let's follow along with the lab guide, make sure we're on the right track. Test connectivity. We configured OSPF. Now let's test routing. Alright, so let's test it the way it wants us to test it. So computer A, can we ping computer C? This is a big test. Ping 192.168.3.3. Yes, it works. Okay, so we couldn't ping that before. Computer A, before we configured OSPF, couldn't even ping the interfaces connected to router 3. So now it can get all the way to computer C, and it can get back. So that's good. So ping back, basically try to ping everyone. Everybody should try to ping everybody. Don't just limit yourself to what's here, just like see what you can connect to. So I'm going to ping 209.165.200.225. Okay, can't find it. That's the loop back. So we haven't really configured that yet. But let's take a look right now what's going on. So I'm going to just pull up router 1. Show IP route. So that will show my routing table. I'll hit spacebar so I see the whole thing. You can see here I've got how many connected interfaces to this router? 3. So I've got 3 connected local pairs. 1, 2, 3. And now I've got 3 networks that were essentially taught to this router by OSPF. So we've got the 10 network in the top right corner. They're not connected to this router, but router 2 essentially taught router 1 about that network. What else do we have? 3.0. So 3.0, that network is connected to router 3. It's in the bottom right. So router 3 taught router 1 about that network. And then we've got this 23.0. Those are the 2 interfaces connecting router 2 and router 3. So either router 2 or router 3 taught, or both together, taught router 1 about that network. So it is, right now, router 1 knows about every single network in the diagram. A key idea is that all we have to do is tell each of these routers to broadcast or advertise information about their local routes, and they'll go off and be chatty, and they'll figure everything out. So what about our loop back? Well, we need to configure OSPF on router 2. We know about one more network. We know about the loopback network, right? So I'm going to go back to config T, router OSPF1, and I'm going to do one more network statement. 209.165.200.224 is the network address. 0.0.0.31 is the wildcard mask. I'm going to use area 0 just to share it with everyone in this network. Hit enter. All right, so it'll take, a few seconds, but that information should start propagating. So I'm going to go to router 1 again, and all of a sudden in router 1's routing table, I see that 209.165.200 address. So we can, just by updating router 2's network statements, automatically we updated router 1, and I'm going to assume that router 3's routing table got updated correctly. So that's great, that's a benefit. If we weren't using OSPF, I would have had to create a static route on router 1 and router 3, potentially, to get to that network. So let's see, computer A, can it ping that IP address now? Yes, we're getting a successful reply. So at this point, let's look at the learning checkpoint. We know how to configure serial interfaces on a router. We know how to set the clock speed. Should be able to identify distinct networks in a network diagram. This may be one of the most difficult parts. Once you get the networks identified, adding the network commands is the easy part, probably. You should be able to describe the difference between static routing and dynamic routing, enable OSPF, configure the networks, and show the OSPF configurations. Now let's see, sometimes people, when they're going through, you enter the wrong network command. Let's just say 192. You enter something wrong. Like, how do you delete that? To find all the network commands that you actually entered, you can run the show run command, and because I'm in config mode, I'm going to prefix that with do. Hit enter. You're going to hit the space bar, space down pretty far. I will see the OSPF configuration here with all of the network commands that I entered. Okay, so if that is the bad one and I want to delete that one, and I would come here to config T, router OSPF1. So I'm going to paste in that network command right there. And I'm just going to say, no network 209.165. Hit enter. Now if I run do show run again, space, it's deleted. So use the show run command to view all the OSPF configuration network commands that you entered, and use the no command to delete any if you accidentally entered the wrong one. Just as a reminder, always here with these network statements, enter the network address, not the IP address of an interface. That's a common mistake that people make. All right, OSPF is great. OSPF can do some amazing things for you, can make your life easier. Essentially, you set up every router, and once that router is set up, they just start sharing information with each other. In this exercise, maybe it wasn't that much easier than static routing, but just imagine if this network started to grow and we had 4, 5, 6, 7 different routers, and we had 20, 30, 40 different subnetworks, that's when static routing is going to kill you. And that's when OSPF is really going to shine. Just set up every router individually and they just share information with each other. All right, OSPF, really cool protocol, and that is dynamic routing in a nutshell.